Alright, 1, 2, 3, welcome back bitches and good morning. And yeah, this is alphabet symmetry, a Codewars exercise in Python. Looks like I'm always in Codewars, but I'll break out of here eventually and do some other stuff. But today, we back in here. You know what I'm saying? Alright, consider the word abode. We can see that the letter A is in position 1, B is in position 2 in the alphabet. Or I read that wrong. In the alphabet, A and B are also in positions 1 and 2. Notice that the D and E in abode occupy the positions they would occupy in the alphabet, which are positions 4 and 5. Your task, my task, given an array of words, return an array of the number of letters that occupy their positions in the alphabet for each word. For example, you're given a list of strings consisting of letters, and you have abode, A, B, C, and X, Y, Z, D, and you return 4, 3, 1. I don't think it's explained very well, but what is actually meant is for each letter in each string, we are to determine if that letter is in the same position that it is in the alphabet. So A is the first letter in this string. It's also the first letter in the alphabet. B as well. O is not. O is not the third letter in the alphabet, so it's disqualified. D is the fourth letter in the alphabet, and E is the fifth letter in the alphabet. So the D and the E are in their spots, correct spots. A and B are. And what we're supposed to do is get a count of each that are in their alphabetic spots. So we compare the string position in the string to the alphabet position. That's the key. And you count the number of each. Kind of a weird concept, but hey, it's practice. So there's four things in the alphabet spots in the first string, 3 in the second string, 1 in the third string. And yeah, you return a list of the counts, and the counts correspond to the strings. There will be the same number of counts as there are strings. So that's how you do it. All right, got to get this in here because I got an appointment coming up and I'm gotta squeeze this sucker in. So probably go a little fast on this one, folks. Okay, I'm going to create a list to hold the counts, and then I'm going to loop through the list of strings. And then for each string, I'm going to get a count of the alphabet stuff in the right index. That wasn't said right. Okay. Yeah, I'm going to do a nested loop because I'm going to be looping through each character in the string to see if it's in the if it's in the alphabet position, or if it's in the same position as it is in the alphabet. Before I do that, though, I need to create a variable to hold the individual counts. Make that equal to 0. And now I'm going to do my inner loop. And that's not it. I'm going to do strings I. Strings I is going to be each individual string in the list of strings. And I'm going to go character by character and determine if that character is in the same position in the string as it is in the alphabet. So looking at this example, you notice that we've got uppercase and lowercase letters. We've got to account for that. Either we've got to make it case insensitive by making it all one case, or we got to differentiate between the cases of letters. I decided to differentiate between the cases, and I'll show you what code I came up with to do that. And in the interest of time, I'm just going to copy my stuff in here and give you a little explanation. Yeah, because what I have to do is compare the character's position in the alphabet to its position in the string. That's the key. So let's look at lines 6 through 9. And we'll isolate on the first, on the if here. Strings ij is the current letter. And we're going to test if it's uppercase. Because if it's uppercase, I'm using ASCII values to determine the alphabet position. And so if it's upper, I'm going to test it against the uppercase decimal ASCII value. So I say if it's upper and if J, which is its position in the string, if its position in the string is equal to its position in the alphabet, then I'm going to increase my count of alpha because I found a match. Position in the string equal to the position in the alphabet. And yeah, this is an offsetting situation where I get the decimal ASCII value and then I minus 65 to offset it to zero-based alphabet ordering. And then I do the same thing if it's lowercase. If it's lowercase, I compare the current position, or not the current position, the position in the string to its position in the alphabet, ASCII-wise. And so once I am done with that, once I'm done with that inner loop, I am going to append my count to my list because I'm going to return a list of counts. And then, really, as you see up here, I would loop back around and my alpha count becomes 0, and I do the inner loop over again for the next letter in the string. Amazing how that works, ain't it? Like my friend Kelly says, amazing. Going crazy here, folks. Losing my mind. All right. Got that, and then once the outer loop is done, it is time to return our stuff, and it's LST. Folks, I think we're done. All right, that looks good. That looks good. All right. On a bit of a time crunch, folks, so I gotta bail out. But y'all have a good one. Here's the code: alphabet symmetry, Python, Codewars. Do it, get it done, do it better than me, and I'll see y'all next time. Catch y'all on the flip.